In a world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice? A flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade, a musician at heart, discovered a harmonic resonance within the ether. He found that his flute, when played with precision, could manipulate this elusive medium. His melodies, a symphony of science, had the potential to shift the very fabric of reality. However, a sinister force lurked in the shadows. The Einsteinian demons. These creatures thrived in the distortion of space-time, causing chaos and disruption. The world needed a hero, and Miller was ready to answer the call. With his flute in hand, Miller played a tune that echoed through the cosmos. Each note, a shot of pure ether, struck the Einsteinian.
All right, hello and welcome to the Celestial Theodolite update. Before we begin, I have a quick announcement to make. Tomorrow at 9 p.m., the official launch of our merch starts. So during the roundtable tomorrow, we will be dropping the links to everything, and you can get all the details and everything for that. And then there will also be a community post on YouTube, Twitter, Telegram, and on Discord, where you can get more information and the breakdown of the sales discounts and all of that that'll be going on for the week of the sale. It'll be a limited run that we're going to be doing from the 7th. I'm sorry, from the 6th. No. Yeah, from the 6th to the 12th to the 13th. Yeah. All right. So anyway, we'll be doing that tomorrow. Here we go. Hola, amigos. I'm joined here today on the Earth Awakening Discord for Celestial Theodolite update number 4. Now, Mike's been busy with his dog rescue, so we don't have any new measurements. So we're just going to be doing a quick recap of what the Celestial Theodolite is. We're going to be going over the most recent measurements that were done really quick, and then any questions, comments that have been put forward since the time that the last one has been. We'll do a little update there, touch base with everyone. All right. So to start us off with the basic premise of the Celestial Theodolite, what is it? Well, if we look over here at vantage point 1, if we have a little lad on the ground with a theodolite and he looks over at that mountain and he takes an angle to it, it's going to measure about 2 degrees and 19 arc minutes. And the question then becomes, is that elevation physically valid, or is it optical? Is there optical compression that's causing that, or is that the physical elevation due to Earth curvature? Right? So there's 2 different predictions that could be made using plane trigonometry. We can make a prediction on whether or not the elevation angle of that mountain is true with respect to that angle. Now we're going to have to introduce a secondary factor though to do this, and that's going to be a star. So we'll get to that here in a second. But first, we calculate out our angle for a flat Earth using just our elevation, the distance to the mountain, and that will give us the angle, the plane trigonometry angle off of that. Now for the globe, you just determine how much of the mountain at that distance would be obscured due to curvature, and that'll be your missing amount. So that we'll have two different relative elevations to our distance here that we're going to calculate. Then we can go into Stellarium. We can go to the peak of this mountain here, and we could set the angle to be what we calculated for a flat Earth. And any stars that intersect at that angle, we write down the time, and then we go and wait. And when that time comes around, if that star gets intersected at that time, that means that the relative angle there that we derived is the physical angle of the mountain. That is the physical elevation of that mountain because it is there blocking the star as we no longer see the star. Now, a lot of people will say, well, what about refraction? How about refraction? Refraction. What about refraction? Well, if an object is no longer visible, it's no longer refracted. So that's the point of this. That's the basis of when we take the time to get our measurement to confirm. So if the Earth is a globe, the premise is pretty simple. The stars will get occluded at a later time because the star has to get lower into the horizon to get lower to that physical elevation that's tilted away from us relative to our distance. Then on a flat Earth, it'll be occluded earlier because the physical peak is actually higher than what it optically looks like. Because at our distance there, it would look like it's 2 degrees and 19 arc minutes, but in fact, the star is being blocked at a time that corresponds to 2 degrees and 31 arc minutes. That was the basic premise and first measurement that was done using Pikes Peak from a distance away from 50.7 kilometers. Now, since then, more mountains have been used at different distances, and we have, obviously different stars that correspond with that. All right, and each one of these is showing the plane trig or flat Earth prediction is the correct prediction, and no times have shown globular predictions, except for one, which I'm sure we'll get into here in a little bit. Oops. There we go. That's our Ether Cause logo there. All right. So here's the most recent measurements here. Now, 1 second. So there was what was it? There was a correction made to the way that Mike calculates and does his estimations here. So the big difference here from the previous celestial theodolite prezzies is this here where it says calculates the altitude of the peak, which is equal to altitude of the observer plus the distance to the peak times the tangent of the true elevation angle that the star was occluded at. And that will give you the actual elevation angle, or I'm sorry, that will give you the actual elevation. Okay, so that's what he's using, just plain trig to derive based off of the angle that it gets occluded at, what the actual elevation would be. And then he has columns here for the spreadsheet, starting with what the altitude predicted by the globe's statistics that are given to us. So like most of the time when you go to Wikipedia and you type in, what is the peak of this mountain, you can get the stats there. So he's comparing that, and we're looking for the difference in the predictions for flat Earth versus globe when we do the plane trig versus the trig to subtract what the missing difference would be for the globe. What we have here are these two columns that show that the true elevation of the mountain peak is for Pikes Peak, all averaged out. It comes out to be about 44 plus or minus what they tell us, plus 44 feet. So the globe difference there comes out to be 246 plus or minus 7 feet. And this is how much should be missing, right? Due to globe drop at this distance, there should be 200 feet missing. So the globe difference there, 246, is what it comes out to be. In other words, the timing isn't matching what the globe predicts. The globe predicts this is physically lower than you. So we're looking at measurement after measurement of the timings not matched. Now, some of these you'll see are negative values. Now, what this comes out to be is that it came out slightly lower than what the values that were the official values that were given, but still still higher than what the globe would predict. So we have all the differences there. And that's all the measurements that we have so far. We can get into questions, comments, and concerns.
I've got a question, if I may.
Mm-hmm.
Did you figure out any resolution on the 2,000 extra feet on the new updated time lapse from Dr. Heffron on Greenhorn Mountain?
I sure did. I'll read you what he emailed me. All right. He says, what Jesse appears to be doing is wrong, is what I mentioned to him in my response in April 8th at 7:28 p.m., which I blind copied into you. Specifically, Greenhorn Mountain, the small plateau directly above the letters REENH of the words greenhorn in your video, is not occluding any of the stars in his video. All of his data appears to be referring to a stars occluded to the range between Greenhorn Mountain and North Peak, not visible beyond the right edge of the screen. Also, Jesse is trying to steer the comparison to complex analysis rather than the simple planar trig, which is the altitude of the peak is equal to altitude of the observer plus the distance to the peak times the tangent of the elevation of the occlusion angle.
So
it seems to be it seems to be an error in your analysis, and you're just kind of still presenting it or whatever. This is what he's saying.
Well, but
and he said he talked to you about it. So
what exactly did I do wrong?
Did you email him about it? Well, you're looking at a place where stars aren't being occluded, I guess, and then attributing the time to that. I don't know.
Did you double check any of this?
I watched the video earlier. Didn't see any stars there.
Which video? The one I put
the one on your video?
After? The one at 22 after?
One at 22 after. Yes.
You didn't see any stars getting included in that video?
At the section where it says EENH or whatever.
Well, stars get occluded all along that ridge line, that skyline, and I did the timings on a whole bunch of them, and every one of them was about giving indications about 2,000 feet too high. So,
well, I don't know what mountain peaks those are, because the Greenhorn one that Mike said is in the bottom left-hand side. I don't know what ranges you're even doing. The error is in your analysis, as he said. You're looking at a different peak, he said.
What? He called it Greenhorn. It's his time lapse. He called it Greenhorn.
The section of Greenhorn is between the letters that I read off. What you're referring to, he said, is a different peak. And he said he talked to you about this on the 8th.
Was there an occlusion by that peak? Is that what you're saying? And you just kind of keep saying it, even though there isn't.
Yeah. Well, this is like we're not gonna keep going in circles here. So, like, is there anything else?
All I can say is check it for yourself. I checked it very carefully on Stellarium, and the star patterns matched up very well for the mountain he claimed it to be. And do your own calculations. Tell me what elevation you get. That's all I can say. I got about 2,000 feet for like the six of them that I tried. 2,000 feet extra.
Okay.
I do have a unrelated question if no one else wants to turn.
Go ahead. What do you got?
So my question is, and I just posted the the diagram. If the light were curving between the star and the observer, would that change the occlusion time? I mean, if the star is setting or rising or whatever.
Is the star visible or not at the time? That's all that matters, Jesse. That's the answer to the question. Is the star still visible or not?
Yeah.
But wouldn't it change the occlusion time? Or would it not? Are you saying it
would
not change?
But would it be visible at a specific time? And then is that the time that it was measured or no?
I'm saying that refraction could change. If refraction was curving the path of the light between the star and the observer, that could actually cause it to be visible after it had set below the straight line geometrical occlusion point. So at that point, it would still be visible longer than it would have been, and still visible and still being refracted, and the occlusion time would thus be delayed, right?
Luckily, we're going with when the star is no longer there, and we don't care at all. We only care when the star isn't there. Doesn't matter.
So are you saying that the light curving would not change the occlusion time as the star set?
I'm saying the only time that matters is when the time the star isn't there. That's it. It's very simple.
Well, the time that it transitions from being there to not being there, that is the occlusion time, right?
Obviously.
Okay, so it stands to reason that if the light ray was following a curved path, that could change the occlusion time, right?
The only time you get is when the time it's not there, Jesse. So it doesn't matter. Whenever it's not there is only what matters. Do you like when you said unreal? Like, all right, next. Do you have another question?
Well, I do. It goes on the basis of the assumption that stellarium gives the true angle with atmosphere turned off. Why does it give it only sometimes, right?
What?
Well, is it an assumption of the Heffron method that stellarium always gives the true physical angle to a star with atmosphere turned off, given the correct date and time and observer location?
Yeah, when you turn off refraction, it's just referencing where it would be like in the nautical almanac.
Okay, so the problem is you could have one person at the top of Pike's Peak with his laptop and stellarium, and another person at the same moment in time at Heffron's house with his laptop and everything, and they both turn off atmosphere, and these two instances of stellarium are giving different angles at the same point in time to the same star. So how do you know which one's the true angle if they're not both the true angle, are they?
Ooh, great question. We know when the star isn't there, that's the true angle. So if the star isn't there, that corresponds to the angle that we calculated, then that's the true angle. That's the beauty of this, and that's why we don't have to. That's the whole purpose of this, was we never told Stellarium where we were at.
Right, Stellarium doesn't know the observer location, only the location of the mountaintop, Jesse's, right? So wherever you see it from, right, doesn't matter because Stellarium still gives you the same output. That's why.
That's our premise.
But stellarium with atmosphere turned off is how we ultimately know the true physical elevation angle to the mountain peak, right? And to the star, right?
Nope.
Not to the mountain peak.
Nobody
Nope.
cares about what you just said.
No, and that would give different predictions at different locations. The whole purpose of this is for that unified triangle at the same time with respect to the geometric positions, the raw trig positions of these places, and the raw uncorrected location of that star. Right, that's the purpose of this. So when you introduce what you're doing, not relevant, you're going to have different values at different places. That's not the purpose of this.
I'm going to take the argument somewhere where it's not.
Yeah, dude, talk about dude, remember when the iteration of the argument was moving the observer to where he isn't or whatever? Like, I'm going to move the arguments where it's not. It's a great one, Beast. Yeah, if there's any other questions or comments, concerns. Hold on one second. I have to
One of the
turn you up,
things
John.
in fact,
Go ahead.
Jesse has always taken this from kind of analyzing the data point of view, and it strikes me that it's worth just looking at the method itself from a purely practical standpoint. And one of the best ways to see that the method itself doesn't work is to apply it to a small nearby peak at sea level, as I've done in a thing. Let me post it again.
post that PDF one more time about a small peak that's like a mile away, then it's not analogous and it's retarded.
Yeah, no, hold on, 1 second, 1 second, 1 second. The sky moves at 4 arcsec or one's what is it? Every 1 second it moves 4 arc seconds, the sky, right? And you're trying to measure an occlusion timing difference of 8 inches. That's an improper use. You're not going to yield a discernible difference there. Nice try. You didn't debunk anything. What you're proposing is a misapplication of the celestial theodolite. And if you could actually measure a timing difference to that magnitude at 4, what is it? That difference where it would be 4 arc seconds, or 4 arc seconds over 8 inches. I mean, dude, that's preposterous, right? But let's say you could do that, right? Let's say you could, you would measure the timing difference, right? So your issue here is the limitation of mechanics to get the difference of 8 inches. That's not, oh, the celestial theodolite doesn't work at 1 mile. Works great over all these distances where we have all these measurements that falsify the globe using plane trigonometry, John.
Small the distance.
Like the smaller the distance, right? The harder it is to differentiate between globe and flat. That's it.
The sky literally moves a greater distance in 1 second, like, than what you're talking about for 8 inches, dude. That's why your analysis is invalid and what you're doing is retarded. You want to go around and parade this 1 mile thing like you've debunked the celestial theodolite. It's you're sad. That's why I'll be here every week to remind everyone. That's been, Dazza, that's been our premise the entire time. Yes. Plus or minus
You have to have
1 second.
Well, then it's not useful. We're trying to figure out what is more accurate. No.
All right. If anyone else has any questions, comments, or concerns, we're going to wrap up.
Just say, hold on, wait. Didn't you just say that there's no difference between flat and globe at a mile away?
Dude, the difference is 8 inches. Like optically you could argue there's no difference, right? But there's an 8-inch difference. That's the difference that's going to be there. So that's what you're trying to measure a difference between using something that's moving at 4 arc seconds a second, dude. Your misapplication of the tool, right?
Nobody cares.
Right? Like suppose you have a wrench, right? And it only opens up a certain amount, right? So you can only grip a nut that's a certain size, right? If you encounter a nut that's too small, are you going to go, oh, the wrench is broken, the wrench is broken, duh! No, that would be retarded. So sit the fuck down, John.
You left.
Yeah,
the whole
did.
point is to say it as slowly as possible so I could try and trigger a response to make it against that, because otherwise I have no position. That's just a
but
clear.
just for the audience, though,
does anyone else want to try to break the celestial theodolite? right?
The point is to tell the
Suppose-
difference, right?
Exactly.
So
Yeah.
we pick big, long observations, and the longer the better, the more distinction. So he's like, you know what I could do, guys, is to find a really short, shallow observation where the difference is negligible, and then I can say the whole thing is invalid. And that's all he had to say, but he'll take 10 minutes to say it in the most smarmy way he possibly could.
Yep. Yeah.
Would it,
It's not one location. It's 1, 2, 3, 4, 5, 6 mountains with different, let's see, 7, 9, 12, 15, 23, like 28 separate observations. So, I mean, I don't know what you guys are talking about.
I also have people that have emailed me that they've done it, but because it's at their house, like you're like near it, they don't want to reveal their location or whatever. But I do have some more things coming or whatever. Like people are out there trying to, are out there doing this. So I recommend we get some Southern Hemisphere brothers. Here's a position that Dr. Bennett took that was really, pretty much the most honest position you could take is saying that, at this place, right, at Mike's location, it just happens to be like super flat there for some reason. And you would have to go and do this at other locations, like across the world. So if we get some more lads across I know, right? But like to be generous, right? So if we get some more lads, especially some Southern Hemi lads, would be nice.
Well, dude, it's funny because in the triangle, like the first survey they ever did when they were doing like Kansas and stuff, they had to write down, it looks remarkably flat, right? We're trying to comport it to a geoid and make it sphere, but boy, it looks flat to every one of our instruments. They had to note that. I remember reading that. So yeah.
Well, according to these guys, it shouldn't work good. Your thing should fall apart in the southern hemisphere because they claim like southern hemispheric refraction because there's like twilight's longer or something. Remember that whole twilight thing? Dusk
Vaguely.
is longer, and they claim like
Ooh.
extra refraction in the south because there's more water or something. Like they got reasons for it at that. So your thing should. What's up?
Hemisphere, particularly in Stellarium.
That was what Zanuck had for why there was extra twilight in the south. I mean, if you got some other reason why there'd be more twilight in the south, let's hear it.
Well, I don't know about the twilight. I'm just thinking.
Yeah,
about
Zanuck does, and he claimed
here.
Zanuck does, and he claimed it's refraction based.
Yeah, I wonder if southern occlusion times would be longer based on longer twilight and dusk. That's an interesting observation. It probably would change with the seasons too then.
Unfortunately, all of my observation points faced east, so I'd have to look at rise times, which is not ideal. And I don't really have I need a telescope with a camera to do it.
Either way, what Alan was trying to say about Dr. Bennett was that to prove that it's not just an anomaly in Mike's location, if you get it done in multiple locations and prove without a doubt that it's not just an anomaly, that's the most fair rebuttal to it, is what he's saying, which I agree.
Yeah, I thought that was a good one, right? I was like,
Yeah.
So maybe it's only Kansas and around Dr. Heffron's house that are the flat areas on the Earth, and that you have to do it at different, like at any place but there to confirm sphericity. It's an interesting position.
Flat or level, Alan? Shane, sorry. Like the Bolivian salt flats, right? They're very level, but they ain't flat.
Well, the guys who measured it also measured the flatness by the timing of a Venus transit. So, who knows, right?
Yeah. Well, we've done there's more modern measurements of the flatness. I know that for Bolivian salt flats, they've got a high resolution GPS study.
Yeah, that references the Venus transit timing. I know. I'm familiar with it, dog.
Yeah, and a spherical datum.
Your premise is my conclusion, dog.
GPS measurement.
No, mate. It's measuring the lat long, dude. It's the same fucking thing as always. Surprise.
Even in ECEF, they need a thing to call the surface, right? So they adhere it to a spherical curving surface from the data.
You can
Nice
measure
try,
the
though.
surface independently in ECF, Alan. I don't want to hijack your thingo, but yeah.
Well, we're getting far off the celestial theodolite again.
Yeah.
Do you have
And
any
that's why the
rebuttals to
celestial
it?
theodolite confuses me, right? Because I know that there are other measurements that clearly show the surface is spherical. The other thing
Didn't-
that'd be really cool with the theodolite would be
No, they see. Here's the thing, though. They don't, though, right? The GPS uses timing corrections to comport it to the coordinate system, so you wouldn't know the difference anyway, right? What we have here, what should unconfuse you, right, is you have your oculars and a watch, and you're just seeing when you don't see a star anymore, and with some plain trig. That's about the most unconfusing thing possible. And so when you, please, shh. GPS time has nothing to do with anything's in the sky, bro. It's atomic clock synchronization. Atomic clocks are synchronized by cesium vibrations. That has nothing to do with the shape of the Earth, my man.
Yeah, but the thing is, though,
Yeah, but what?
the
Yeah,
GPS
but what?
Alan, chill.
Nah, man, this is so dog shit. We have a plain trig measurement here that's not referencing anything that's already pre-cooked, and he's confused. Get unconfused.
shape of the Earth from one point. That's the other thing that confuses me here, right?
Well, I hope you find clarity.
'Cause you don't have any angle measurements as such, right? You're just doing the timing based on stellarium's prediction and published altitudes.
You don't have any angle measurements.
Yeah, 'cause
Oh.
physically measured, right, actually line up with.
All right, 1 second, Daza. Before we continue, does anyone else have any questions?
I would like to go over a specific one if we could when we have time.
No,
Check my
Well,
mess.
we don't.
I have a question.
I just remembered we don't. What's your question, Shane?
Is the suspect guilty or is he not guilty?
No, that's a
Right,
great
so-
question.
Put him for the analogy with a security camera on top of the mountain, make it a building, right? And there's a dude committing a crime. And if he's there at the time, then he's guilty. And if he's there at any other time, he's not guilty, right? Super easy. No wiggling out of it. No trying to make it about something else. Is the suspect guilty or not guilty?
Like I said, neither one's guilty. The flat Earth suspect was 2,000 feet from the crime.
Nope. There's one suspect. There's no multiple realities, timelines, alternate universes. None of that shit.
And it's a false dichotomy to say just because one suspect is not guilty that the other is guilty.
It was committed at the one time. And
It's
he was
a
there and
mutually
not there.
exclusive
It's very
outcome. No hypothesis. Like, what do you, dude? All right, man.
A binary
It's
choice.
it's been real, lads. It's been a slice. I'm gonna go ahead and close out. Gio, thank you for being a wonderful host. All right, lads and ladettes. We are out of here. Stay tuned for tomorrow's Prezi and the merch launch.